Let's move on to the next half of complex mechanics. And the nice thing about the second half is there's not going to be anything new whatsoever. It's going to be more of the same questions, but there's going to be one minor change. And actually, I still have a rough sheet of paper here from a solution I was working out to some of the previous work. Here's what's going to change. We did a previous question, actually all of the previous questions. There was an object that was traveling at constant speed, and there was an object that was accelerating. And the nice thing about that is it usually made for one easy formula and one slightly complicated formula, and it made it easier to substitute the formulas together. There's no guarantee that you're going to have one object traveling at constant speed and one object accelerating. However, if you have to use two acceleration formulas, once you substitute in your givens, you're still only going to have two equations, two unknowns, and it's always completely solvable. So what I did this time was I took the same situation as before, Tatum versus White. If you read this paragraph here on your page, that'll just explain what I just said, that sometimes you have two accelerating objects. And at the bottom of the page, if you read this description, it's changed. It's the exact same situation, but I've reworded the entire thing. In this new situation, Tatum and White are not going to be heading toward one another. So White is going to, if I draw a quick little diagram here off to the side, White is going to catch the ball, and he's going to start to accelerate away, and Tatum is going to be behind him. He's going to accelerate after him. And some distance down the way, White's going to run some distance, and Tatum is going to run and catch up, and they're going to meet. That's going to change things a little bit. So what we're going to do here is we're going to fill in the givens list, and for each one of the questions on this page, I think that's what we're going to do. We're going to fill in the givens list because, as I was saying in class, once you have the givens list made, the rest is just math details. So the important thing about the questions today, firsthand, is to get the givens list down correctly. So we're going to do one question together of the givens list, and then there are two practice questions on this page that I'm going to get you to work on your own, but we'll go through the givens lists together, and then you can work out the rest of the question. At the end of that, there are two questions that I'd like you to look at that are more advanced. I got both of these questions in university, and I want to see if you can make heads or tails of them. We'll go through full solutions to these, and I'll probably actually make a video solution for them. But let's go back to the front page, and let's read this description and create a givens list. I'm going to zoom in really close so that you can see the givens list itself. And let's read this paragraph together, follow along, and design the givens list together. White caught the ball 30 meters in front of where Tatum was standing. Actually, you know what? I'm sorry. Before even reading this paragraph, read the last line. Let's find out what we're looking for. How far did White travel? Right there. How far did White travel? That's what we're looking for. So let's immediately identify that in the givens list as distance x. And remember what I said in the previous video and the previous class. Wherever you put your unknown for distance, also put your unknown variable for time. It's easiest to put both of the easiest versions of the variables in one object, because that will make it more likely that that object's formula, when you write it out, is going to be a relatively easy formula. And it also gives you an idea of how to think about the distance for Tatum and the time for Tatum. Okay, let's try this again. White caught the ball 30 meters in front of where Tatum was standing. White was already in motion at 2 meters a second. So White's V1 is 2 meters a second. White accelerated away from Tatum upon catching the ball. Tatum hesitated 2 seconds. Let's use that right away. Tatum hesitated 2 seconds. So White goes running, and he runs for time y. Tatum waits for 2 seconds. Be careful with that. That means that Tatum is in motion for 2 seconds less than White because he waited. So Tatum's time, if we write down y minus 2, because he runs for 2 seconds less than White, that will tie those two things together. Back to the description. Tatum starts from rest, so Tatum's V1 is 0. Tatum accelerated at a rate of 0.4 meters per second squared. How far did White travel before Tatum caught up to him if White's speed was exactly 3.5 when he got tackled? So his V2 is 3.5 meters per second. So we're almost done. We just have to take White's distance x and make a corresponding distance for Tatum. Now this is a chasing question. So think of it like this. If White runs distance x and Tatum has to chase after him, they were 30 meters apart in the beginning. So Tatum has to run that 30 meters and has to run the distance x that White will run. So Tatum's distance is going to be 30 plus x. So Tatum has no V2 given, and White has no acceleration given. If you write out a formula for Tatum and substitute in these givens, and you write out a formula for White, it'll be a different formula because the combination of variables is different, and substitute in the values for White. You will have two equations with the same two unknowns in it, and your job is to substitute those equations together and work out the math and solve for x and y. And in the end, all you really need to solve for is x. But always substitute them together the easiest way possible, even if you solve for y and have to solve for x after. I'm not going to go through that on the page because I think at this point, the hard part is done. This is what I wanted to sort of talk you through, and maybe you're even going to repeat this and listen to it again. The math details from this point down are going to be pretty straightforward, and the final answers, you can look them up on the answer sheets. The second question that you're going to do is I wrote out a funny little situation here, or I thought it was pretty funny, where Mr. Germano opens the doors to the elevator and jumps into the elevator shaft and lands on top the elevator that's got a bunch of seniors in it that are going down in the elevator, writing Vape Nation on the wall of the elevator, and just riding the elevator when they shouldn't be. So Mr. Germano is going to be an accelerating object that's free falling faster and faster and faster. And actually in this case, I thought all of these questions were going to be two accelerating objects. Not in this case. The elevator is descending at constant speed. So let's design the givens list together, and then you can work out the actual solutions and check them out. First thing I will do is go to the very last sentence and see what we're going to solve for. How many seconds will he fall? So right away on Mr. Germano's time, I wrote variable y, and I typed it right on the page. That's what we're solving for. Similar to the hint in the last question, if Mr. Germano's givens list is where variable y is going to be, let's put variable x on distance as well. Because in these questions, it's always going to be distance and time that you're going to tie together. Now let's read the question and compile the rest of the givens lists. Several non-handicapped students pile into the school elevator and begin riding it downward at a constant speed of 0.5 meters per second. Like a scene out of Mission Impossible, Mr. Germano pries open the doors of the elevator shaft and drops down into the hole. The elevator roof is already 1.5 meters below him and descending. So he's going to fall into that elevator shaft, and he's going to catch up to the elevator. Now, what do you do with this 1.5? Let's try and make sense of this very carefully. So, when the elevator door opens, how can I draw this? Here's the elevator. The elevator has already descended 1.5 meters. He's going to jump at that point. The elevator is going to go down further, and he too is going to drop down further. So the elevator is going to descend, and he's going to descend, and they're going to catch up to one another. Think about this very carefully. If Mr. Germano's distance falling into the elevator is x, then what is the elevator's distance? It started off 1.5 meters below the door when Mr. Germano fell in. So Mr. Germano fell the 1.5 meters and whatever comes after that. The elevator, when this question begins, just moves whatever comes after the 1.5, the 1.5. So be careful. The elevator is not going to descend as much as Mr. Germano. He falls a lot further. He falls distance x. The elevator descends x minus 1.5 because it doesn't need to descend that 1.5 meters that it had already descended before the question began. Okay, what else? If he hesitates for 2 seconds before he drops. So let's be careful with that. Mr. Germano is going to fall for time y. But he hesitated. So in other words, he wasn't in motion for 2 seconds. He stood there and did nothing, watched the elevator descend, and then he jumped. So if Mr. Germano falls for time y, and he waited for 2 seconds, the elevator's been moving for y plus 2. The elevator has been in motion for 2 seconds longer than Mr. Germano falls. That's all that's mentioned in the question. That's not enough. Mr. Germano's givens list is far too empty. But there's some obvious things here as usual. He starts from rest, and he free falls. So acceleration is 9.8 meters per second squared. So Mr. Germano has no V2. That will allow you to look at these variables and write down a formula for Mr. Germano and sub in those variables. And just by looking at that variable list, it's going to be a very easy formula with 0 and some variables with no other numbers tacked on. That'll be a nice easy formula. The elevator, constant speed, write down the formula, sub in these variables, and you will have 2 formulas to put together. And I will let you at that point turn to the written solutions, and you can look and follow the work or see if you did it right from there. Lastly, the third question. This is a question where a car is going to drive by a police officer at the side of the road with a radar speed trap, and the police officer is going to accelerate and catch up to the car. So think about it this way. If I draw a quick little diagram, here's the police officer. I'll write down cop just because it's a little faster. Police officers at the side of the road. A car zooms by. The car is going to travel some distance, and the police officer is going to chase after it. And they're eventually going to be at the same place. They're going to catch up to each other, or the cop is going to catch up to the speeder. Let's look at the givens list. And again, very first thing you should do is look at the last sentence. How far will you drive to catch up to the speeder? How far will you drive? You're the police officer. So right away in this question, I identified the distance for the police officer as x. And my hint to you again is wherever that unknown variable is, make either distance or time, whatever the other variable is in that list, make that the other unknown variable. So in effect, your 2 easy unknown variables are in the same givens list, which will result in an easier formula for substituting afterwards. So let's read this question. A car flies by you at 130 kilometers an hour. Well, that's going to need to be converted, and I don't have a calculator right beside me, so I'm gonna leave that. car flies by you at 130 kilometers an hour. So V1 for the speeder is 130 kilometers an hour, and please convert this into meters per second. I'll leave that up to you. The driver immediately notices the police officer, and takes their foot off the gas, hoping to slow down without flashing their brake lights. They decelerate at 0.12 meters per second squared. A negative sign for slowing down, 0.12 meters per second squared. It takes you 5 seconds to buckle up and tuck your lunch away, your donut, I guess. It takes you 5 seconds before you chase after them. So, you chase after them, you drive, your time is Y. They have already been driving for 5 seconds. So when you eventually catch up to them, if it takes you, let's say, 30 seconds to catch up to them, they've been in motion for 35 seconds. So their time is Y plus 5, not Y minus 5. Think about that. There's another detail in the question. With your lights flashing, you accelerate at a rate of 2 meters per second squared from rest. So your V1 is 0, and you accelerate 2 meters per second squared. Almost done. The Gibbons list for U has no V2 in it, so we're ready to choose a formula and sub those in. The speeder, we need just one other thing. The distance. We need to have a corresponding distance. So if you drive distance X, and sometimes this happens, this is a question where I did this on purpose because I wanted it to be in your notes. If the question begins as soon as the driver passes the cop, and even though the driver is driving at a different speed and the cop has to accelerate, when they meet, if the driver drives distance X, there's no difference. The cop drives X as well. That happens sometimes. There's not always a difference in time or a difference in speed. Sorry, not speed. A difference in time or a difference in distance. You can have the same distance. So even though we don't know the distance, if your distance is X, the speeder's distance is also X. No V2. That will allow you to choose a formula. It looks like it's going to be the same formula for both U and the speeder. Sub those variables in. Make sure you convert that V1 into meters per second, which I haven't done yet. And you're going to find that the formula for U is much, much easier, especially with that 0 and the easy variables. The formula for the speeder will be a bit more complicated, and it looks like this is going to have quadratic formula. Combining these two together will lead to quadratic formula. So I hope you can get a quadratic formula calculator or cell phone app, or be in front of a computer and use a website, because I don't want you to waste time subbing in manually to quadratic formula. Okay, so as well for this question, check the solution out. I'm going to write out a solution that matches exactly what I've got written here, and I don't think you need to go through that on video. You can follow that in a solution set. And this is what we're going to work on in class in the second session on Monday. I'm going to get students to do these 2 additional practice questions together, and we're going to take them up. And to end off complex mechanics, I am going to leave the cohort that's in the room with these 2 questions to try out. Now there's something different about both of these questions. Notice how I said advanced homework questions. I don't want to skip all the stuff in grade 12 that is advanced. I know I want to try and make learning during COVID as easy as possible and as succinct as possible, but I also want to make sure that you get exposed to things that you're going to need next year. So, do question 1. It's a girl chasing after an ice cream truck, and you have to calculate how far she runs to catch the truck. And question 2 is all variables. There are no numbers mentioned in question 2 at all. It's all a stone is dropped from height h, a ball is thrown upwards with speed v1. It's all variables. We got question number 2 on one of the first assignments in physics at Brock University in 1998, and I remember the work group that I had, we almost lost our minds when we saw that this was the question. We had no idea how to do it. But we were under the mentality from high school that questions that had no numbers in it were impossible. And I want you to try question 2 if you can. I want you to try question 2. I want you to try it with no numbers whatsoever, but do it exactly the same way you would do it if you had numbers, and see what happens. You're going to find that it actually works out, and it works out rather simply in the end. I'm going to have to make a video for this, or we'll take it up together when you get back if you're not in class. And I'll post either a video solution, or I'll post an update that we'll take it up when we get back. But give it a try, see what happens. Don't worry if you can't answer it at all. Give it your best shot, and don't worry about getting it right or wrong. Just give it an effort.